The first thing that happens is a painful stimuli. We'll say a nail injury on the hand. So let's explore the progression of that stimulus. That injury will recruit immune cells, like mast cells, macrophages, and neutrophils. These cells will release inflammatory mediators such as prostaglandins, bradykinin, ATP, hydrogen ions, serotonin, and histamine. All of these mediators go out and stimulate their respective receptors on the nerve fiber. For example, on this dendrite of the first order neuron, there are prostanoid receptors for prostaglandin, there are beta 2 receptors for bradykinin. ATP will then bind to ATP-sensitive potassium channels and close them, resulting in depolarization. At the injury site, the first order neuron will further amplify its signal in subsequent reaction with the release of substance P and calcitonin gene-related peptide, or CGRP. These neurotransmitters cause vasodilation, histamine release, and sensitization of pain, otherwise known as allodynia. The best example of this is the feeling following a sunburn, where you are more sensitive to even light touch. The peripheral nerve is known as the first order neuron. When it is stimulated, its impulse travels back to the spine via A delta and C type myelinated fibers and synapses in the dorsal root ganglion to a second order neuron before ascending the midbrain, pons, and medulla. Glutamate, substance P, and CGRP are all released from the presynaptic terminal. Note that only substance P is illustrated here. CGRP binds to CGRP receptors, resulting in neuronal changes, which essentially allows the neuron to have a lowered threshold to fire action potentials. Glutamate is a very key neurotransmitter in this process. It will activate postsynaptic NMDA and AMPA receptors, allowing the influx of calcium and sodium respectively. Positive charges coming in will result in a synapse. Substance P binds to NK1, which leads to intracellular signaling. This leads to nitric oxide synthesis, arachidonic acid pathways, and further activation of NMDA receptors. Substance P helps to further activate those NMDA receptors by binding to NK1, being taken in, and activating protein kinase C. Protein kinase C then travels over to the postsynaptic intracellular NMDA receptor and removes a magnesium ion that allows increased and prolonged activation of NMDA. This will increase the pain signal.